Okay, now let's carry on the next part. We're going to look at this worksheet here, which is going to be focusing on what we call volumetric analysis. In this case, it's really just about dealing with the concentration of the substances, which are normally also solutions. So we are dealing with the concentration of solutions. Now, if you can remember in our flow diagram, when we look at concentration of solutions, they can either be in mole per dm cube, or they can be in gram per dm cube. Okay, so we're going to look at how we're going to revolve around finding the concentration of these substances. Okay, so let's start ignoring all these initial questions. Let's just jump straight into this. Okay, so let's read this question here. So the household bleach contains aqueous ammonia. Okay, contains aqueous ammonia. So aqueous ammonia is actually NH3 lah, aqueous. So which is this. They say 25 cm cube of household bleach. Okay, so this is the volume of the solution. Volume of NH3 solution. Requires 21.5 cm cube of 0.125 mole per dm cube of dilute sulfuric acid. So this is the volume of H2SO4 in terms of the solution. This is the concentration of H2SO4 in terms of the solution. Now, take note, knowing what's the quantity that's given to you is important. Okay? So now, next. What's the question asking us to find? They ask us to find the concentration of aqueous ammonia in mole per dm cube. Okay, so I want to find the concentration of NH3. Okay? In mole per dm cube. What's given to me, I got volume of H2SO4, con of H2SO4. So generally, volume is, I won't use the volume of H2SO4 because volume of solution actually doesn't tell much. It's normally the concentration of H2SO4 that will be like the quantity that you will say you're starting with. So con of H2SO4 to con of HNO3. To do this, okay, now take note of this mole per dm cube. Okay, mole, con to con, so cannot. So I first need to find the mole of HNO3. Mole of NH3. Okay, find the mole of NH3. To find the mole, once I found mole of NH3, then I can get the concentration. But what's given to me is the con of H2SO4 first. So to find mole of NH3, I will need the mole of H2SO4 first. Then I can find the mole of NH3. So you realize based on this, it's 3 steps again. So concentration to mole of H2SO4, I'll need to multiply by its volume. So that's where you got your 21.5. Okay. Once I found the mole of H2SO4, I can use the mole ratio. Multiply by the mole ratio. In this case, the mole ratio will be, oh no. Oops. Okay, I think I need to rewrite this whole thing again. Okay, pardon me. Let me now rewrite this whole thing again, because the thing got you cancelled out again. Okay, so it will be con of H2SO4, which is in mole per dm cube. Okay, you can do a quick recap of this. I'm gonna find the mole of H2SO4, and this is done by multiplying by the volume of H2SO4. To find the, then after from mole H2SO4, I'm going to find the mole of NH3. This is multiplying by the mole ratio. In this case, this will be 2 over 1. And lastly, to find the con of NH3, I need to divide by the volume of NH3. Okay? In this case, it will be the household bleach, which is this one. Okay? So there's 1, 2, 3. So 3 main steps. So let's start. First step is to find the mole of H2SO4. This will be equivalent to taking the concentration of H2SO4 multiplied by the volume of H2SO4. So this will be 0.125 multiplied by 21.50. Now, this is the part that I need to highlight to everybody. Now do take note that the quantity is different. What do I mean? If you look at the concentration is in dm cube, but what is given in the volume is actually in cm cube. So you need to convert the cm cube to dm cube. So take note, if I want to convert cm cube to dm cube, I need to divide by 1000. So what I'm going to do here, I'm going to take 21.50 divide by 1000. So this will be my initial step. What I'm going to get is 0.0026875 more. Okay, realize I didn't run off the 3SF is really because the 3SF should be always at the final answer lah. So I'll try to leave it as to about, if I want final answer 3SF, I'll leave my working to 5SF. Okay, 2 additional ones. Okay, next one. Once I find the mole of H2SO4, I'm going to find the mole of NH3. So this is done by taking the mole of H2SO4 multiplied by the mole ratio. In this case, it's 2/1. So it's 0.0026875 multiplied by 2. What I'm going to get will be 0.005375 mole. Okay? And the last step is to find the concentration of NH3. So how to do this? I'll take the number of moles, which will be 0.005375 multiplied, sorry, not multiply, I mentioned here divide. So divide it by the volume. In this case, the volume that is given here is 25 cm cube. Now, if you just divide 25, which is a common mistake, you're going to get it wrong because they want the units to be in per dm cube. So I need to convert the 25 cm cube to dm cube, so I must divide this by 1000. So if you were to work out your answer, it will be 0.215 mole per dm cube. Okay, this is left in 3SF. So this is your final answer. Okay, so you can see here the steps are generally about the same. Okay, the steps are generally about the same. Now let's try another one. Let's do question 4 over here. Okay, so question 4 says X gram of sodium carbonate is dissolved in 250 grams of distilled water. Okay, then 25 cm cube of solution Y required 20.50 25 this forms solution Y. So 25 cm cube of solution Y requires 20.50 cm cube of 0.125 mole per dm cube of nitric acid. So this is the volume of nitric acid, HNO3. This is the concentration of HNO3, okay, to reach the endpoint. So I got the nitric acid concentration and volume. This solution Y here is actually this 25.0 cm cube is actually my volume of sodium carbonate. So V of sodium carbonate, Na2CO3. Okay, so the question wants me to determine the concentration in grams per dm cube of sodium carbonate in solution Y. So I need to find the concentration of Na2CO3. Okay, that's what they want me to find. To do that, but this is in gram per dm cube. Now, the interesting thing is to find the concentration of Na2CO3 in gram per dm cube. I cannot just straight away find the mole of Na2CO3. I must first find the concentration of Na2CO3 in mole per dm cube first. Okay, only from here that I can convert to there, correct? So that's the thing. Now to find the concentration of Na2CO3, I need to find the mole of Na2CO3. Okay, so you can see here, convert all the way to mole. Now from the top, what is given to me starting is the con of HNO3. To find con of HNO3, this one is quite nice. It's actually in mole per dm cube already. So to find the mole of Na2CO3, I need the mole of HNO3. To find the mole of HNO3, I will need to take the concentration multiplied by the volume. So you can see this one here now requires 1, 2, 3, 4. There are 4 main steps. So first one times the volume, I will get the mole of HNO3. HNO3 to convert to Na2CO3, I need to multiply by the mole ratio. So this is mole ratio. Now, let me erase all the numbers here first, because I realize it's affecting my working. Okay, so the mole ratio for this would actually be 1/2. Okay. Now, to the mole of Na2CO3 to calculate to the concentration, I must take this divided by the volume of Na2CO3. Now, there's actually two volumes here, 250 cm3 and 25. But in terms of the reaction, actually it's only 25 cm3 that's reacting. So I'm going to use the 25 cm3 one, not the 250. Okay. So that's the concentration. Now with the concentration of in concentration of mole per dm cube, I'm going to convert to gram per dm cube. You know, mole to mass is multiplied by mR of Na2CO3. So this is 1 step, 2 step, 3 steps, 4 steps. So this is to find the concentration. Actually realize there's one more part here, which is 5. We'll go into that later on. Okay, so let's do this. First thing, let's find the mole of let's use NR, the big N. Mole of HNO3. To find this, I am gonna use the concentration, which is 0.125, multiplied by the volume of it, which is 20.50. Now take note, because it's dm cube and cm cube, I must convert the cm cube to dm cube, which is divided by 1000. So if I were to do this, I am gonna get 0.0002562 mole. Okay, so this is step 1. Next, I'm gonna find the mole of Na2CO3. In this case here, it's taking 0.0025625, which is the mole of nitric acid, multiplied by the mole ratio, which is 1/2. I am gonna get 0.00128125 mole. Okay, with that done, I'm gonna go into step 3, which is to find the concentration of Na2CO3. How to find the concentration? This is actually taking the mole. Okay, this one is a mole per dm cube. Take the mole, which is 0.00128125, divide by the volume, which is 25.0/1000, because must convert to dm cube, right? So if you were to do this, you are gonna get 0.05125 mole per dm cube. Okay. Last one. Step 4. To find the concentration of Na2CO3 in grams per dm cube. This is equivalent to 0.05125 multiplied by the mR. This is where you say, oh no, I haven't found the mR yet. Then how? So let's find the mR here. So mR of Na2CO3, this will be equivalent to 2 times 23 plus 1 times 12 plus 3 times 16. So this will be equivalent to 106. So this will be actually 0.05125 times 106. You are gonna get 5.4325 gram per dm cube. Now, what does this mean? It means that I got 5.4325 gram dissolved of Na2CO3 dissolved in 1 dm cube, which is 1000 cm cube. Now, they want you to find the value of X, which is the mass of sodium carbonate, a mass of Na2CO3, okay, which was dissolved in 250 cm cube. So in a sense, if 1000 cm cube requires 5.325 grams of sodium carbonate, what they're asking you is, how about 250 cm cube? What's the mass involved? What's the mass in 250 cm cube? So you realize, okay, just simple proportion. So X will actually be equivalent to taking 5.4325, which is the mass in 1,000 cm cube, multiplied by 250 lah. So you take this, this to find the mass in 1 grams, mass in 1 dm cube, multiplied by 250. So if you were to do this, your final answer, if you round off to 3SF, will be 1.36 grams. 1.36 gram. So this is the value of X. Okay. So nothing too tough, nothing too exciting. So this will be for the volumetric part of it. Okay.